Yeah, I'm currently, yeah. So everything you say is in the video I'm making.
Thanks, man.
All right, people, here's a video for Tools of Geometry Objective 1. Definitions that we're going to need for this are going to be translation, reflection, rotation, and a new one that you might not have heard about yet is going to be dilation. So a translation. So I really like to think of a translation as a slide. Now, I'm also, whenever I tell you guys about these, I'm going to, and we'll see some examples when we get into the diagnostic questions, but a thing you should remember is that for a translation, you need a line of translation, and that's going to kind of take you from one point to another. So it'll be something like that. It'll take you from one spot to another. A reflection, I like to think of that as a flip. And a flip is going to need a line, line of, that looks weird, doesn't it? I don't like that. And let's take, I'll rewrite dilation. That feels in the way. All right. I'm talking to my computer and my students via computer. That was Mr. Fisk, guys. Nobody likes him. Don't worry about it. So you need a line. I'm just kidding. I like You need a line of reflection. Now, that's going to be something where, like, if I have a point and then I have a line, it's going to get flipped over to the other side of the line. But anytime we talk about a reflection, you're going to need to identify that line of reflection. And then finally, a rotation is going to be a spin. Now, spin or rotation is one of the more complicated ones because you need a point of rotation. You also need a number of degrees. So that could be, you know, maybe it's 90 degrees, maybe it's 180 degrees. But you need a number of degrees, and then you also need a direction, which is going to be either clockwise or counterclockwise. Either clockwise or counterclockwise. So a rotation, I think about, I'm always going to have a point. So let's imagine that I have a triangle and it's going to rotate around that point. Well, if it, let's say it goes 90 degrees clockwise, it's going to go around that point, almost like, I like to think about it like a clock, like the hands of a clock going around the point. So we'll look at a couple of rotations, but remember I need those, there's three big things that I need when I talk about a rotation. Okay, so these are important because these are all grouped together, and all three of those are called rigid transformations. Now, what rigid means is that they don't change the size. Don't change size. All right. Now we have one other one. I'm going to give it its own little, we'll give it its own little box down here. Okay. A dilation. A dilation, think about your eyes dilating when you go to the eye doctor. A dilation, it makes a shape bigger or smaller. So it is very different from the other three because the other three just move something from one place to another. A dilation actually changes its size. So those are our four, right? So like one, ooh, no, not that. Right, so we have, well, let me change to highlight. Okay, whatever. Well, we have four. 1, 2, 3, 4 transformations. 3 of them are rigid, 1 is not. Let's look at some of these questions. Only one transformation was used to create the blue line from the red line. Okay, so we have to start here and end here. So think about, how could I get it from one place to another? Well, right away, these two are the same size. If they're the same size, that means dilation is off the list because the dilation would make it bigger or smaller. Okay, so then what can I do? Well, translate is a slide. So if I take and I slide the whole thing along that line, that seems like it would work. So translation is a possibility. Rotation, now rotation seems a little bit tricky. Actually, so the other obvious one, reflection. I think a lot of us would see that if I reflected, now reflections are interesting because they have to be, I have to have my line of symmetry. So my line of symmetry would actually be here for reflection. Now you're like, Mr. McSparron, how do I know where the line of symmetry is? Well, it has to be equal distances from both the beginning and the end, or the pre-image and the image. So let's count. So if I start here and I go 1, 2, that's 3.5 spaces. And then if I start here, I go 1, 2, 3, and it's 3.5 spaces. So because these things are equal distances from that line of reflection, I know that it could be a reflection that creates this. Now, rotation is a little bit more tricky. Let's erase some of this. Okay. Now, rotation, I need a point. All right, so my point would actually be right here. And if I think about attaching that red line to that point and then rotating it 180 degrees, if I swung it all the way around out here, it could actually end up right there. If I rotated 180 degrees, it would end up where the blue one is at. So if I could rotate it so that the red would land on top of the blue, then that works. So all three of the rigid transformations, translation, reflection, and rotation, would all work for that one. All right, which transformation maps A, B, C onto D, E, F? Now, the thing I want to show you guys here. So, come on. You don't let me highlighting? Well, that's upsetting. It's not let me highlight. It won't let me erase it. All right. Well, so let's think about, I want A to go to D. All right. So A has to go to there. B has to go to E. All right, because the first one has to match with the first one, the second with the second. B has to go to there, and then C has to match with F. It has to go to there. So now I start thinking, well, just sliding wouldn't work, because if I was going to slide, all of these would have to be the same length, right? Because if I slide, then the whole thing goes the same distance. So if these three things are not all the same length, it can't be a slide, right? So slide like that's out. Well, they're the same size, so it's not a dilation because it doesn't get bigger or smaller. Okay, so dilation is out. So let's think about a rotation. Well, if let's say I attached this and tried to spin it around here, the problem is that it's kind of in a different orientation. Like you can tell that it got picked up and flipped over. So if you can tell it got picked up and flipped over, then we would say it's a reflection. So the answer to this one is just reflection. But for reflection, we do need a line of symmetry. So think about this. If I have those connectors like this, the line of symmetry has to be halfway between the 2 points. So if I could find the halfway point of B to E, the halfway point of C to F, and the halfway point of A to D, that would give me my line of reflection. Now, I didn't draw it very well, but you guys understand what I'm saying. Find the halfway points of the connector lines. But the connector lines, remember, have to match up A to D, B to E, and C to F. All right. Oh, this one's fun. The line XY and JK are shown. So it's got XY is drawn in right here. And what it wants me to do, it says if JK is reflected over. So I'm reflecting, I'm going to take JK and reflect it over to there. Now, You have to figure out exactly where it's going to land. And I didn't put all of the other graphs on here, so bear with me. I'm going to show you how to find where it goes. So JK, let's think about this. It has to be the same distance. So if I could draw a line there, it has to be the same distance over to there. And K, if I could draw a line there, it has to be the same distance over to there. Let's try and figure out how we could actually do this. So I'm going to do this. I'm going to go J, if I go over 2 and up 3, it's going to get me to the line. All right, so that was over 2, up 3. Well, if I just do the opposite, if I go over 3 and up 2, that will put me where my new point needs to be, which is going to be L. Now K, let's say I go over 5 and up 2, all right, over 5 and up 2. Well, now I'm going to go up 5 and over 2. Up 5 and over 2, and that is going to be my new line, LM. So we think about just doing, there we go, and now, yeah, you can tell JK got flipped over to LM. I'm talking to my computer, and then my students when they watch this video. All right, guys, so that pretty much does it. I know this is confusing, so make sure you ask questions if you have them, okay? Good luck.